Hello everyone, and welcome to the return of SKULLTRAIL series. In the previous episode, I installed the right coolers, installed Windows, and ran into a few issues. Today I'll address those problems, and I'm finally going to be overclocking to see what $2,400 worth of CPUs from 2008 are any good today. So previously I found out that the CPUs were reporting wrong temperatures, and I was rather clueless as to what the problem was. However, I was contacted by Dan Powell on the previous video, who left a comment saying that the temperature bug is a known thing to the QX9775 CPU, and that he owns two that have the same issue. For him, there are two sensors which report the temperature correctly in hardware monitor. This, however, was not the case for me, but after some back and forth with him, he concluded that for me, in SpeedFan, it also shows two correct temperatures. So we know that these two temperatures are correct. A huge thanks to Dan for helping me out solving this rather crucial issue. Moving on, there are two more things which will require cooling before we can start to turn up the voltage. The first one being the Intel 5400 North bridge. Even though it may not seem like much with this rather small heatsink, it actually has a TDP of a whopping 38 watts and usually reaches about 75 degrees under load. As the manual of the motherboard recommends, I've now put a 40mm fan on it, and this has dropped the temperature to about 60 degrees. The second thing requiring airflow are the 4 fully buffered RAM sticks. As you can see on the sticker, these things can get pretty hot, which they do at over 90 degrees Celsius. Even though they are designed to run at these temperatures, I would like it to get as much heat from the system as possible, so I placed a Intel CPU cooling fan on them, which decreased the temperatures to a little over 60 degrees Celsius. Moving on to the actual overclocking, I first started with the RAM. So as I just showed, I've got 4 DIMMs of 4GB Samsung FB DDR2 RAM, which is rated at 667 MHz. At the timings of 55515. Leaving everything at stock, this results in a score of 670 points. You might notice that the RAM actually runs at 640 MHz, which is because it doesn't run synchronous with the frontside bus speed, limiting it to the next best thing, being a 5:4 ratio at 640 MHz. Going into the memory overrides menu, we can alter the memory from its stock settings. I first wanted to see if I could get the timings at stock speeds better, and found the timings 44412 or CAS latency 4 to work just fine as well. This raised the performance a bit to 675 points. I even tried CL3, but that wasn't going to work on this RAM. Next I moved to raising the actual clock speed itself. Reverting back to the CL5 timings, this kit turned out to have absolutely no problem operating at 800 MHz, almost 20% faster than stock. This improved performance yet a bit further, now to 680 points. Impressed by the performance so far, I continued pushing it by now raising the frontside bus, and found it would still work at an impressive 840 MHz. Nearly 26% faster than stock, all the while not having touched the voltage of the memory, and keeping the CL5 timings. Unfortunately, changing the frontside bus also increased CPU frequency, so I can't compare it with the previous tests. Moving on to the CPUs, I'll keep using the RAM at 800 MHz with the CL5 timings. First I'll changed two settings before overclocking started, which was disabling spread spectrum and enabling enhanced power slope for both the CPUs. With this generation of chips, Intel still provided information on the core voltage. In this case they have rated them for 0.85 to 1.35 volts. This page also states that the chip is rated for a T-case, being the temperature at the heat spreader, up to 63 degrees Celsius. I wanted to find out 3 different clock speeds for the CPU. max clock speed at stock voltage, the max clock speed at a safe everyday voltage, and the clock speed limited by the coolers I have now at a higher core voltage. So now that I know the temperatures to keep in mind and the voltages, it is a matter of turning up the frequency until the system becomes unstable. In the processor overrides menu, we can change both the multiplier and frontside bus speed, since these processors are unlocked. You might ask, why not just use regular Xeons instead, as those can be overclocked by the frontside bus as well. And while this is certainly true, they can only be overclocked so far, because as I mentioned previously, changing the frontside bus also changes memory speed. This makes the memory the limiting factor when it comes to overclocking via the frontside bus. This issue is solved by being able to change the multiplier with an unlocked CPU. I first looked at the max clock speed at stock voltage. If left on automatic settings, the motherboard will automatically increase the voltage when raising the multiplier, so I have set the lowest possible manual voltage, which is 1.285 volts. At this voltage I reached 3.86 GHz, using a multiplier of 9 and a frontside bus increase of 7 MHz, an impressive 660 MHz over stock clocks, which gave a score of just over 800 at 802 points in Cinebench, an increase of nearly 18% over stock clocks, using only a hair more voltage. Moving on to 1.35 volts, I reached nearly 4 GHz at 3.95, by raising the frontside bus 11 more MHz. This boosted the score to 820 points, now tying the stock Core i7-4770K, and gaining over 20% performance compared to stock. I was fairly surprised at this, as it seems most reviewers back in the day didn't get past 4 GHz at 1.4 volt, and after much more testing and throwing caution in the wind using 1.415 volts, I reached a quite amazing nearly 4.2 GHz on all 8 cores, resulting in a Cinebench score of 861. That's nearly a full gigahertz over stock speed. I even got it to boot at 4.3 GHz at the same voltage, but unsurprisingly it wasn't stable. Still, I'm more than happy with 4.2 GHz, as for now this is the max voltage I'm willing to use, as temperatures were already far exceeding 63 degrees. So I'll either have to wait for colder weather, or buy better coolers before pushing it further. To put these scores into perspective, I've made a small chart to compare it with various other CPUs. As you can see, when clocked at 4.2 GHz, the SKULLTRAIL comes close to a stock Skylake 6700K, with the Hexacore Coffee Lake i5 and Kaby Lake 7700K further ahead. Perhaps far more interestingly is that it is significantly faster than AMD's flagship 8-core CPU from 2014, the FX9590, despite it having a higher clock speed at 5 GHz and using much faster DDR3 system memory. So do I think this great showing of performance will continue in games? Well, unfortunately I don't think so. Cinebench is perhaps the best case scenario to show SKULLTRAIL's performance, as unlike with more unoptimized workloads like games, little core-to-core communication is necessary here. With chips like the AMD FX, all 8 cores are situated on the same chip, making for quick core-to-core communication with relatively low latency. Looking at something like SKULLTRAIL, the 2 4-core chips can only communicate via the North Bridge. This increases latency and is bound to hurt performance in applications like games, which aren't as beautifully optimized as Cinebench. In conclusion, I am more than impressed by the overclocking capabilities of both the RAM and the processors. I was quite worried that these CPUs wouldn't be great overclockers anymore, since they could have had 10 years of previous owners pushing them to their limits, as they were usually bought specifically for that purpose. But with nearly 4 GHz at a safe voltage and a stable 4.2 GHz at a higher voltage makes me very happy. I'm also pleasantly surprised by the flexibility of the fully buffered RAM. Given the fact it is buffered, I wasn't quite sure what to expect, but with a stock 667 MHz, overclocking all the way to 840 MHz. Makes me very impressed. Well, that was all for this episode. If you have enjoyed it, please do consider leaving a like. If you have a comment or a question, do leave that in the comment section or ask me on Twitter. If you want to be kept up to date on the project, consider subscribe to this channel as well. In the next episode I'll be putting these chips through their paces in games to see how that works with this complicated yet powerful system. Well, thank you for watching and bye bye.